Hello, my name is Brandon Smith. Today we're going to be talking about the Splint Master materials from DTAX. So they have two for splints called the TAF and the Flex. So one is obviously a flexible or soft night guard material. The other is a hard splint or night guard material. So we're going to talk a little bit about those. Before we get into the specifics, I would like to direct you to their website. So their website is really nice. It does have a lot of good information. There is a lot of information in here about the different resins that they offer. So right now I'm on the Splint Master TAF. So I'm going to scroll down here and show you a little bit of the specifics on the material and why I like it. It's got a good strength to it. They also like to put their IFUs and things like that on the website. So one of the cool things about the IFUs are they are very all-encompassing. So this is the IFU for both the TAF and the Flex. So when you scroll down here and find the intended language that you speak, you'll be able to find all of the processing information here, which is really nice. The biggest things to keep in mind here when you're doing this is how long the alcohol baths need to be, what the minimum thicknesses need to be. So for example, here you can find the minimum material thickness for the design for the Flex is 1 millimeter, for the TAF is 0.8, which is really great. Um, then you can find a lot of the post-processing and cleaning information located in here. So if we scroll all the way down to the annexes, you'll be able to see that information. Um, so some things to keep in mind with this particular material are that it is a 3-minute alcohol bath, so twice. You need to use clean isopropyl alcohol. It needs to be at least 98%. It's really important. You'll also need to cure it in a cure box that has the nitrogen gas. That will give you the clarity that you need. And then there are only certain printers that are validated for it. So right now you've got the Asigas, you've got the Ivoclar, and you've got the Rapid Shape. So if I zoom in here a little bit, you'll be able to see that. So um, that is nice. So the Asiga Max is what I typically will go ahead and print all of mine on. The 4K is nice, but it's a volume printer. So if you're only doing a couple splints, you'll want to use the Max, and the Max will fit quite a few splints on it. So that's what I'll be using. And as you scroll down, the cleaning information is here for each different type of machine that it's validated through. Also, the light cure is here as well. So when you look through these, you'll see, for example, I like to use the ultrasonic bath. Um, so you're going to do the main cleaning performed in a separate vessel with fresh isopropyl alcohol, purity at least 98% for 3 minutes. So you're going to do that twice. Um, so then once you do that, you're going to dry it real good before you put it in the cure box. So making sure that you download these IFUs and really use them is huge for the success of your prints and how well they come out and the strength and clarity of the splint as well. So now let's get into design. So I use 3Shape to design all of mine. Um, Splint Studio in 3Shape is really, really good. It's really easy to use. It's quick. So you'll be able to knock these out pretty quickly in here. It's really intuitive. It's got a great virtual articulator, so you can function these in and get them really close. So let's get into it. So the first thing that you need to know is how to enter the order form. So I'm going to go ahead and open this up so we can take a look at the order form. And then from there, we'll go into the design. So this is the typical order form. This is obviously generic. It's not a real case. But to set up your order, really all you need to do is select all the teeth in the arch. So if you want to do an upper, select all the upper teeth. If you want to do a lower, select all the lower teeth. And then go down to appliance, and then it should default to these splints. The material here is not going to matter because we're going to choose that in the design. So don't worry about it choosing zirconia or anything like that, because we will get the correct material in the actual design software. Um, the next thing that you'll have to watch for in here is the design module. So it should always be on Splint Studio, not on Appliance Designer. Splint Studio is leaps and bounds better than Appliance Designer for these, so always use Splint Studio. And then your object type under scan settings, this will tell the software whether or not you're scanning models on a lab or desktop scanner, or if you're receiving these scans from a digital impression system. So that's really the only settings that you need to worry about in here. So I'm going to close back out, and then we're going to go into Splint Studio. All right, so now that our design has loaded and we are in the software, we're going to go ahead and start the process. So the first step here is the prepare step. There's two things we're going to do here. The first is set the occlusal plane. We're going to do that by clicking 3 points. So if you notice on the left here under occlusal plane settings, it tells you where to place those 3 points. So you've got 1, 2, and 3. So we're going to do that in the exact same spot. So I'm going to click 1, I'm going to click 2, and I'm going to click 3. That sets our plane for us. The next thing we're going to do is we're going to go up to machine and materials. So right now it's selected at none. So we actually need to set a machine and a material in here. So if we select this, it'll give us a listing of all the different machines and materials that we can use. So first we select our company of our machine. I'm going to use a Sega, so I'm going to click in there, and then I'm going to use the Max 2. And you'll see that the DTEC Splint Master tap is in here. So I'm going to select that. It'll come up with all the settings. You'll notice the minimum thickness, the splint thickness, all the settings in here. So that's really all we need to do. Now that we've selected our material, we're going to go ahead and close out. Now that that's selected, we've got some hints on here, but we don't need to do anything else. So we're going to go ahead and select next at the top left. And that's going to take us into our bite configuration. So really, when you receive these from your doctor, or if you are a clinician and you're trying to do these in your office, there's really two ways you can do this. You can manually open the bite here. Now, keep in mind that this is just a generic virtual articulator, and the relationship of the actual scans to the condyles is not accurate. So just because you set it here and you think, you get it all functioned in and you, design it, print it and everything, and it comes out, the bite could be different based on, the virtual articulator versus the articulation system you're using physically versus what the patient's actually doing in the mouth. So there's a lot of room for error here. One of the things that will make this a little easier is if instead of arbitrarily opening the bite based on the splint thickness that you need, you could also have the doctor or you as a clinician could open the vertical and protrude the mandible if you want to do that, and then scan the bite that way so that it's already open here and you don't have to do this step. If that were the case and it were already open, all you would need to do is come over here to the left and click this lock jaw position, and then that will set it, and then you can move forward. But since this case was scanned in centric, we have to open the bite ourselves. So we need to make room for the splint. So there's two ways you can do it. The first is you could use this opening value here and set it to whatever opening value you want. Most clinicians usually do 3 or 4 millimeters. But if you don't know that that will be enough, the other option is to come up here to where it says ensure space for splint thickness. You can set this at whatever minimum thickness you want for the splint, and then you can hit this little bite arch opening button here, and it will pop open to give you that minimum thickness throughout. So you don't have to worry about thin spots. So it could open it more than what you think it should be, but that's basically what it does. Now, there is another piece to this. So if you wanted to, you could also protrude the mandible forward or change the bite a little bit here. So If I click on one of the arches, so let's say I click here, left click on the lower, it'll turn yellow like this and give me all these control points where I can then go ahead and grab it and move it. Now you'll notice as I move it, it's telling me how much I'm moving it. So if the clinical directions are to open the or move this mandible forward a millimeter, I can do that and I can stop right here and I've just moved it a millimeter forward. Uh, if that's the case, then I'm good to go here and I can go ahead and lock my jaw position and now I have it locked to exactly where I'm going to design the splint at. Once I have it locked, I can go ahead and select next. And now I'm going to look at the undercuts here. So there are quite a few undercuts. This patient has some brackets that were placed. So one of the things that we're going to have to do on those is either avoid them or go just around them up here and not engage down further onto those teeth, which, depending on what material we're using, we can or do not have to do that. With this case, it automatically performed the path of insertion for me, and all these blue markings are basically undercuts based on that path of insertion. So you can see some of them are quite a bit deep, while others are not so much. So um, you can also add relief wax here. So if you want to put in some relief wax, it will relieve a lot of these areas where it's getting the markings. So as soon as it calculates here, you'll be able to see that. Some of the other settings here, you can put in block out angles. You could do things like that. So I like to use the relief option because one of the areas where I always have to adjust is in the interproximals. So you can see different degrees of the relief will give you more or less block out wax in there. I think 100% is a little extreme, so we don't need that much. But um, maybe 50% would work. So we'll see what this looks like when it generates here. So that's a little bit better, not quite as extreme, but then you can also go down even further depending on what your needs are. Really what we're trying to do is keep it from engaging into the undercuts and the interproximal where the teeth kind of come down underneath the contact area. So I think right here would probably be good enough for this case. So I'm going to leave that. The other settings that you'll see up here, so you got block out angle, so you can set an angulation to the block out. So it will taper as it comes downward from the top. So you can see the direction that the arrow above the scan is pointing. It will actually taper from that outward. So that's what the block out angle does. And then the retention amount will basically allow you to engage if you have performed undercut removal on, then what the retention amount will do is it will analyze the depth of these undercuts and it will allow you to actually engage into those slightly based on your retention value. So if you, let's say you have a millimeter in there, for example, then it will allow you to engage into undercuts that are a millimeter or less deep. So you would be able to engage into a lot of these, but maybe not some of these under the brackets, for example. So that's kind of how that works. Really, the retention amount, you want to use that on more flexible materials like the Splint Master Flex. You could use that on, but on the TAF, I would recommend not using it because that TAF material is not real flexible. So when you go to push it on, it's going to get held up and won't flex around the teeth. So I'm going to use these settings here and I'm going to go ahead and go next. And then I can do some wax trimming here if I want to adjust any of the areas where I've placed wax. I'm going to opt not to. I like what it did here and it gave me the right amount of block out wax. So I'm going to go ahead and select next. And then now I need to draw my outline. So this is going to depend a lot on what kind of splint you're designing, how much retention you want, and things like that. So I'm going to come in here and I'm going to start drawing it. Um, I'm going to attempt to avoid some of the undercut areas. If I do grab into some of them, it will be very minimal. Um, Unless I'm using the flex material, then I will grab full down into the undercut areas to give it a little retention because again, that material is more flexible and it will flex around those areas. You can see I've got these brackets here, so I'm going to go across the bottom area, but basically the area where it sticks out the furthest. That way I can guarantee I'm not going to be in any undercuts, but it will have, some tooth to hold on to there. Then I'm going to go kind of straight across here on the anterior. I like to minimally engage the anterior teeth just because I don't want it to lock on because of the buccal lean that they have. And then when I get back to the posterior here, I'll start to go back down, kind of do a little bit of rolling up and down the buccal surface of these to give it some retention. Then I'll go around the back. And then I do mine a little differently. So sometimes if I put it just on the teeth, the plane of the splint will not contact the opposing teeth because when you open the vertical, those anterior teeth get further and further away. And if you don't protrude the mandible some, then there will be no contact there. So one of the tricks I've learned to do this is to actually come down slightly onto the teeth or onto the tissue and go ahead and draw my outline here. Um, you'll want to get, fairly close to the teeth, but not on the teeth. And then this will allow you to extend that back a little bit into the palatal area. This side might be a little too much, so I'll go ahead and once I've finished my splint outline, I can go ahead and redraw certain areas if I want to fix them. But that's probably pretty close to enough here. Um, it doesn't need to be too far back, but it just needs to be slightly back so that, like I said, the lower teeth can actually contact with the splint itself. Um, if I need to, I can adjust settings here. Now that this is depending on if the material is locked or not. Splint Master is not locked, so I can adjust these settings as much as needed. So I'm going to drop this down a little bit because I don't want the splint to be overly thick. It'll be uncomfortable. And then the offset from teeth, you'll want to leave that alone unless you're having fit issues. So if it comes out too tight, you could adjust that and make it bigger. If it comes out too loose, then you may want to lower that a little bit. Drill diameter, you're never going to have that turned on for printed materials. That's only for milled materials. So I'm going to go ahead and go next. And then it's going to give me basically what looks like a suck down style splint on here. What I need to do in this step is tell it, am I going to do a ramp? Am I going to do a flat plane? Am I going to do intercuspation on this? What kind of splint am I going to make? Now, typically for me, I always do the raised surface to the cusp tips. That's basically the basic night guard that we make. If you want to define it out by a flat plane and then function into that flat plane, that's fine. It can be a little bit time consuming to do it that way just because it takes a little longer to function those in. And then you have your ramps if you need to do an anterior ramp or anything like that. We're just going to stick with the regular raised surface. Now, one of the tricks I have found to make this a little easier on me when I'm functioning these in is the areas where you have the least amount of space is typically these last molars. So when I define out where I want my raised to surface to go, I actually don't include those. I stop right in front of them. And this will help me function it in a little easier. That way, these areas, these last molars will just be the suck down style, whereas the rest of it will have that intercuspation. So I'll have a little bit of extra space back here. Sometimes, once I get all this functioned in, it'll probably drop right in and not really have any space. So now we can see that it gave me my functional areas. Um, it's kind of flat through here, but it's suck down style back here, which will help me. So um, you can do combinations of these. So if you wanted to do this style with a ramp in the front, you would just highlight the areas where you want the flat or the intercuspation, and then highlight the other areas, select the other icon, and highlight it where you want the ramp. It's really simple. So I'm going to go next. And now what it's going to do is it's going to bring back in the virtual articulator here, and we're actually going to be able to function this. So I'm going to turn this on. And what we're going to do is we're going to make sure that Guide by Design is turned on. And then we're going to run the articulator. And you'll see it's going to mark in blue where it's got contact. And then what I can actually do is I can use this push design feature here to just adjust those blue areas in. So as I do this, I should start to get more function across the whole thing, which is what I want. I want, all the teeth to actually function across it. So I should be able to do this in a few moves. So if I hide some of the things here and show you just the splint, as I do this and I function this in, you can see these red dots. These are my initial contact points. And then all the blue markings are where I'm actually getting functional movement. So what I want to do is I want to get this to where I actually get functional contact in the anterior. That's usually the hardest part to get. So I'm going to keep functioning this in until I get that. And I can watch it as this goes on so I can see exactly what's going on here. Now, let's say I'm starting to get thin spots like this and I don't want to continue to function it in. What I could do is I could come in here with my add tool, turn my strength down a little bit, then go and add some along those anterior teeth to attempt to help it get some functional contact there. So you can see I gave it a little bit of that functional contact, and then I'll adjust it in a little. And now you can see I've got some contact back there. So you can really get these dialed in pretty well if need to with certain teeth. Sometimes when they have a bit of a roller coaster occlusion, it's harder to get those function in. So you can help it out a little bit by establishing some areas of functional contact. And then you can run the articulator and function those areas in. Because if you just add them, you may have added a little too much. So in this case, like this tooth right here is hitting real heavy, so I want to adjust this in until I get more of my contacts back. So that spot is really, really heavy, so I can actually do the opposite here. I can take away a little bit and then rerun it and let it. So now you can see I got my contact back there. And then as I continue to do this, the other thing that you'll notice is the red areas on here. Those are areas where you're extremely close to the opposing, but not quite there yet. So a lot of times functioning these areas down will give me a little bit better functional contacts. So now you can see I've redeveloped all of my contacts on this side. And then the last thing, let's say once you get this functioned in, then it's just kind of blending it, making it a little smoother, um, so it's not as lumpy. You'll want to avoid, function areas, obviously, as you do this. And then the last thing it's going to make me do is any of these thin spots. So I'm going to hide functional contact and I'll hide some other things here. So I'll hide the occlusal map, and then you can see here that so this is going to be a thin spot. So I'm going to have to bulk that up. Um, Luckily, under the validations, it will show me thin design 0.5 millimeters. So I can hit correct here, and it will go ahead and bulk that area up for me automatically. So um, that fixes it. Now that I've got it all functioned in and it's ready to go, I can go ahead and select next. And it'll ask me if I want to do an ID tag. I typically don't do ID tags in my splints, so I'm going to skip over this, but you are more than welcome to. You just add it, type in here what you want it to say, and then you'll lay it on the splint and then rotate it. So I'm not going to do that, uh, but you can. So I'll go next, and this will take me to the end where it saves and closes out. And then we'll take a look at generating the STL files and sending those over to the printer. So all in all, these designs typically take about, you know, 10, 5 to 10 minutes. They're not really all that long, which is really nice. That makes it easier to do. I mean, if you're, processing your splints with acrylic, that's very time consuming. It's very technique sensitive. This is a lot easier. Then once you get into the printing technologies, it just makes it so much better. So now I've got my splint here. It's saving out right now and generating my STL for me. So now it's ready. So if I right click on it, I can go down to advanced, generate the CAM output, and then it'll load here a second. What it's doing is it's creating a folder, then it's generating those STL outputs and putting them in that folder for me. So now I can right click on it again and go to Explore CAM, um, and this will take me to the folder. So here, it gives me two files. This PTS file, this is a basically a point cloud that tells me where the margin would be. So that's just the area where I laid my outline. That's really only needed for milling, but what you'll need is this STL file here. This is going to go into the printer. So if I double click on this, this will be my STL of my splint. Um, so that's really it for the design piece. The next thing we'll look at is the printing, and we'll look at the nesting of these. All right, so now we've designed our splints. Now we need to take it and nest it so we can print them. So this process is really easy. So this is my Asiga Composer software that I've got open here. Um, I'm going to go here to the new option, which is this page with a plus, and it's going to open up all of my available printers. So I'll be able to choose whichever printer I want. So I'm going to go ahead and nest it on one of my Maxes. So I'll select the Max, and then I'm going to go down here to the material, and I'm going to find my Splint Master material. So I'm going to choose the TAF, but the Flex and the TAF, you nest them very similar based on the IFU. So we'll just use the TAF for this. 100 microns is good. You do have the ability here to choose different trays. So one of the things that I would suggest is if you get really, really good at dialing in your splint designs and you want to try this, you can. Um, I don't think it'll work as well with the flex because the material is too flexible during the printing process. It can move more, but with the tap, you could do this. You could use the ultra gloss tray. You could actually nest it with the heels down with no supports, and it will print the whole thing. The only stipulation of that is when we were in the design, what you would have needed to do is add some extra material underneath the heels of the splint, so that when you set this on there on the heels, you'll just pull it down slightly and you'll leave it like that with no supports, and it should print just fine. What this will cause is when you post process it and everything, as long as you're curing it with nitrogen gas, it will come out crystal clear and polished already, and then you won't have to go to a pumice wheel and pumice and polish it, which is huge. That saves a lot of time. Um, so either tray that you choose is fine. I'm just going to leave it on the default, and I'll show you the traditional way to nest these. So I'm going to select OK here, and it's going to pull up my build platform for the printer I selected. So the next thing I'm going to need to do is I'm going to need to add my part, or my split. So over here on the left, Asiga does a really good job of making these workflow bars. So I'm going to click the cube with the plus. I'm going to hit select file, and then I'm going to navigate to my STL file for this. So here it is right here. So I'm going to select it and hit open, and it'll actually identify what it is and orient it the proper way for me. So I'm going to hit open here, and you'll see that it puts it up like this. This is exactly the positioning that you want it in, so that it doesn't, you don't want the supports on the occlusal surface, but you also don't want them on the inner surface either. So what I'm going to do is I'm going to go to the support button here, and I'm going to go ahead and hit apply. So that's all the supports that we'll have on this. Now, sometimes it'll do these model inner supports. I am not a fan of these, so I actually turn them off. And when I hit apply, you'll notice that there's no supports inside. I have found that it prints fine this way. Sometimes, like I said, with the more flexible material, you have to have those inner supports in there, otherwise it will not print properly. So I'm going to leave it like this without. And then the next thing I'm going to do is I'm just going to move it into the center of my build platform. I don't like to put things off to one side or the front or the back. I like to have them centered. If I have multiples, then I'll load up the center first, then I'll do the outsides, just because with the way printing technology works, especially on these Asigas, sometimes what can happen is if you have one thing on one half of the build platform and nothing on the other, the forces of separation when it goes to peel away from the bottom of the resin tray to build the next layer can pull that side and actually cause the build platform to tip out of alignment, and then you'll have failed prints. So I like to put stuff in the middle first. And then from there, what I'll do is I'll go over here to the print button. So it's this bottom one, and I'll name my print. Usually I'll name it something that has to do with what I'm doing. So this is, DTAC Splint Master TAF. And then I will go down here. You can turn fast print mode on or off here. It'll save you about 40 minutes worth of print time. So that's up to you. If you're not going to be sitting there waiting on it, or you're printing it at the end of the day, really not a need to put fast print mode on. I have found that it prints with either just fine. So you can have it on. You don't need it though. Separation detection turns on with fast print mode, so just leave that on, and then we'll hit next. I like to have the shadow base under it so that way when I go to print this, it's not all these little individual supports that are touching the build platform. They're actually all connected to each other with a big base plate underneath that part. So that way there's no issue with the stability of those, shifting or sliding side to side as it prints. So I like to leave it on shadow here as the type, and the base plate thickness is fine. Then I'll go ahead and come down here to the bottom and hit the print button. And this will create the slices, and it will send it over to the printer. So from there, that's really it. Now we'll go over to the printer and we'll start the print. All right, so now we've got our designs done. We've got our splints nested. So now we're ready to go ahead and load the printer. So we have a couple options here as to resins to use. So the first we have here is the Splint Master Flex. So this resin here is going to be very flexible. You're going to be able to squeeze it and bend it and twist it. It will return to form though once you do that. And then you have the taft. So this is going to be more of a rigid, non-flexible splint. So like your hard splints. Really great material. As long as you do the post-process and everything properly, it'll come out really nice and clear. You can use the Ultra Gloss tray from Asika, and that will allow you to have it come off the printer like it's already been polished. Um, or you can use a regular tray, do some polishing afterwards. So what I'm going to do is I'm going to grab my tray here and I'm going to open this up and take my tray out. So this tray is already preloaded with the resin. So you can see that on the tray there is a fill line that's very faint, but you can see it right there. So you don't want to fill it any more than that. Otherwise, when the build platform goes down, it will cause the resin to erupt out and spill all over the inside of the tray or inside of the printer. So we don't want that. So I'm going to slide this in. Now, there is an RFID tag here, this little white label. So you always want that to face the back right corner of your printer here. So I'm going to go ahead and put that in, slide it down, and then I'm going to seat it. So there's a lip at the bottom of the tray that will seat around the glass at the bottom. So you want it to sit in there, and you'll feel a little wobbly in there. Then you'll want to lift up your handles, push inward towards the tray, and release. And what you'll see are these little washers here on the four corners of the tray will hold on to it based over this lip here on the around the edge of the tray. So that's how it kind of locks in. Now you'll see that it doesn't move at all. Then you'll want to close your lid here and go ahead and go to your print option on the screen. Select next build and then select your print. Now, it will come up with an option here to shut off the printer when it finishes with the build. You can do that if you'd like, if it's the last print of your day and you don't want to have to come in here and manually do it, or if this is going to print after you leave, you can go ahead and select this option here, and then you'll hit continue, and then it will make sure that you have both the right material and the right tray in the printer. And then you'll go ahead and hit yes here, and then that will go ahead and start the print. So now our case is printed. So we're going to take it off of the printer and take it over for cleaning. So the first thing we'll do on our Max UV here is we'll open the hood, and then you can see that our splint is on here. So I'm going to lift this up, release this knob here, and slide the build platform off. And now you can see that we've got our splint nice and printed on supports on here. So now we're going to take it over to our alcohol bath station and we're going to go ahead and uh, take it off of here, cut the supports off, and post-process it. All right, so now we're over here at our alcohol bath station. I'm going to go ahead and take this off of the build platform. So to do that, I'm going to use a X-Acto knife with a chisel blade on it. So that is what it looks like. Nice squared top. It's got a bevel at the very end. You can purchase these on Amazon for, $10. So what I like to do with this is I like to take it. You can see that there's a little base that it puts under the supports here. So I'm going to get up underneath that and I'm going to pry that off. So you can see how easily it comes right off here. So now I've got my split on supports. And now what I'm going to begin to do is I'm going to use a little set of snippers here, and I'm just going to cut off the supports as close as possible to the splint as I can. The supports come off pretty easily, so it doesn't take a whole lot of time to cut these off like this. So I'll go ahead and get these off. Those come off really easily, so I'm going to toss that in the trash. And now I'm going to take my splint and I'm going to put it in a small container here with 99% alcohol, isopropyl alcohol in it. So what I typically want to do with this is I want to put it into where the fit surface is facing up. That way the alcohol doesn't pool in there, and I'm only going to put enough alcohol in there to cover the appliance. This will save you a lot on your alcohol. Um, so now I'm going to go ahead and put it in my ultrasonic here, uh, and I will put it in here for 3 minutes and go ahead and start it up. I'll do 2 alcohol baths with this, and then once it comes out, we'll go ahead and air dry it. All right, so now we've finished our alcohol baths. So I'm going to go ahead and pull it out of the ultrasonic here. We're going to go ahead and dump it into our dirty alcohol container here. So I always use a filtration device so that if I'm doing any small parts, I can go ahead and catch those in my filter here so as not to have those fall down into the resin. So I'm going to take this, I'm going to air dry it real good. And what I'm going to do is I'm going to inspect it for any tacky or wet spots that I can see. What you really want to get out of this is you want to be able to see the whole surface be matte. So one trick with this is if you don't get it completely matte like I did here, I can take a little bit more of my alcohol and I can go ahead and put it in a container. And then I can take a brush, could be a toothbrush, it could be one of these, and I'll dip it in here and I'll actually kind of scrub the tacky spots with this, and that will help me break up the free resin, and then I'll take it and I'll go ahead and dry it. And then what I should see is a nice matte finish to it with no tacky or shiny spots on it. So that's what I'm looking for there. So now what we're going to do is we're going to take it over to our cure box and we're going to go and put it in there and we'll go ahead and start that up. All right, so we've got our splint here. We're ready to go ahead and put it in our auto flash. So what we're going to do is we're going to flip on the gas. We're going to set our timer at 2,000 flashes. We'll open it up here and then we'll go ahead and stick this in. It does not matter which side you start with because what we're going to do is we're going to put it in here on the mesh. Then we're going to do the 2,000 flashes. Then we'll flip it over and then we'll do 2,000 more flashes. Make sure that your gas is turned on and then you can go ahead and hit your start button there. All right, so now we've got our splint completely printed, cured, and ready for final finish now. So what I like to do is using my hand piece, I'm going to take first this guy and I'm going to go ahead and use them to finish off the main part of the little connectors there. And then I'm going to use this other one. This is a Scotch-Brite wheel to go ahead and smooth those areas up. Once I do that, then I'm going to go back to this guy and I'm going to check the fit on my model. I'll check both the fit of the appliance and I'm also going to check the bite itself and make sure that I'm not getting contact prematurely here in the posterior before the anterior. So we're going to go ahead and do this now. So I'm going to flip on my hand piece and I'm going to go ahead and start working on this. So And you can see that these finish off really easily with not a lot of force needed. And because of the way that they're nested, being vertical as they were, there's less supports than if I did these with the splint actually just laying flat. So that's going to help with the finishing process quite a lot here. And because this is now final cured, I can touch the splint like a normal splint with my bare hands. I don't have to be concerned about contamination from free resins or anything like that, because this is actually finally cured, so there's no issue there. All right, so now that I've got the little supports finished off, I'm going to take my Scotch-Brite wheel here, and I'm just going to go in, turn down my handpiece speed a little bit, and I'm going to go in here and just smooth these areas up. And I always do the feel test just to make sure that I've got them fairly smooth. Alright, so that's pretty smooth. So now I'm going to do a fit check. I wanted to go on with some retention and be a little bit difficult to remove, but not super hard to get off of here. So it actually slid on pretty well. You can see the accuracy of the fit there across the anterior teeth. Looks pretty good, but it looks like my bite is slightly held open. So I'm going to go back to my carbide tool here, and I'll take a little bite paper and go ahead and function this guy in. So I've got my bite paper here, and I'm just going to come in here and tap it. And yeah, we can see right here I've got quite a bit of an interference there, so I'm going to go in here and finish this down. Still getting quite a bit here in the center. So now I can see it starting to actually close down. So I'll continue to use the bite paper on it and function it in. This material grinds really nicely, so it doesn't take me a whole lot of time or effort to function this in if I have to. Now ideally what you would want to do is you'd want to make sure that you get this pretty well functioned in the design itself before you do this. Now I had some issues with some high spots because of material thickness, so mine was a little bit high back here in the posterior, which you'll find, sometimes you don't get quite the minimum thickness that you need in the vertical opening. So you want to make sure that you function this in at this stage so that you can give the doctor and the patient a really nice functioned in splint. You just want to be careful here. You don't want to go through the splint, obviously, in the posterior, because then the patient will have some issues back there with it. So just continue to function in my bite here. Until I get this all completely functioned in. And what I'm really looking for with this style of splint is that I get the function or the contact in the anterior. This is more of a night guard style, so the patient will be wearing this at night to keep from grinding, and so I want to make sure that I get all the teeth into some kind of contact here, otherwise it could fatigue the patient as they sleep, which we don't want that. And we are getting it quite nicely worn in. The posterior looked like it was pretty high, so we are almost touching now here in the anterior region, so we are definitely really close. But you can just see with minimal effort how easily it is to function this in. I should have this here in the next minute. Starting to get a few anterior markings here. Just want to get some here in the around the centrals, and then I should be pretty good to go. And now we can see that we've got our anterior contacts now. So we can go ahead and polish this thing. So now I'm going to take it over to our pumice station, and I'm going to pumice and polish it. All right, so now we've finished our splint. Now we need to pumice and polish it. So I had to grind in the occlusion a little bit. So now I need to go ahead and polish it out, pumice it out, and then polish it. So I'm going to go ahead and do that here. So got a normal pumice and polish station here. So I'm going to start on the pumice side, then I'll jump over here to the polish side. Just trying to get the scratches out on this side. So we'll go ahead and start up here. So I've got it scratches out pretty well. Um, so now I'm going to go ahead and take it on here and I'll go ahead and do my polish on it real quick. So I've got it all nice and polished now. I'm going to go rinse it off, and then we'll take a look at the final product. All right, so now we've polished up our splint, and it is ready to deliver. You can see it comes out really nice and clear, even with the polishing. Looks really nice. It fits the uh, model really, really well. Nice little pop that you heard there. Um, so the patient will have some good retention from this, and uh, we'll be able to wear it for quite a long time. This material is really strong and it holds up really well in the mouth. We use it here at the lab quite a bit. Um, so that is it on designing, nesting, printing, and finishing the Splint Master series from DTAC.